No
Is
problem.
it fine?
Your voice is enough.
Yeah, voice is clear, no? Yeah.
Yes, yes. We will proceed. Archana madam, please.
Can I get the share permission? Share is okay. Right?
Just we will introduce you, madam. Then we will.
Then fine, sir.
Archana madam, please proceed.
Yes, sir. Yes, sir. A very good afternoon to you, ma'am. Dr. Chandra J, currently working as Associate Professor in the Department of Computer Science at 26DEC2022, Bangalore. She received her Doctorate of Philosophy, PhD in Computer Science from Hindustan University, Chennai. And she had published many research papers in international journals, and she had a membership in ISTE, IEEE, IANG, and many others. I would like to continue Dr. Chandra J to continue this session with her topic on the machine learning.
Thank you, madam. Shall I start? Thanks for your wonderful introduction. Let me start. Can I start, sir?
Sure, ma'am. Sure, ma'am.
Okay. I wanted somebody to, confirm my screen. I hope my screen is visible.
Yes.
Is it visible? Yeah.
Yes,
Is that fine? Okay. Can I start?
yes, ma'am. Yes, ma'am. It's fine.
Yeah. Thank you, madam. Yes, yeah. Thanks, Kiran sir, and the coordinators and the management of the college for giving me the continuous opportunity to address the audience as well as the eminent people here sitting, well-versed researchers. So very good afternoon and warm welcome again for the session. I will be actually sharing my research experience with respect to machine learning, how it is used for the society to solve the healthcare related problems. I'm currently working with four.
హైట్ తక్కువ ఉండాలి ముందుకు వచ్చినా వెనకుండా బుడుగు ఉండేవాళ్ళు చెప్పాలనా
Yes. Excuse me.
Madam, please. We have muted them, please.
Yeah, fine, sir. Fine, fine. Yeah. I am currently actually concentrating on healthcare research. So that's where I'm actually trying to use a machine learning model for each problems. I started with actually predictive model for solving insurance field, but I was not happy with business intelligence and business analytics. But my interest is actually with respect to medical field. So I started with my research scholar. We developed a predictor model for recognizing the cardiac problem with respect to the heart arrest. So that's where we build model, and it was actually well appreciated by radiologist and the cardiologist. And right now, actually, she is working as a research fellow in Texas University, USA. So that's how my journey started. And the next machine learning research project is actually we are trying to develop a model which will do combination of a CT scan as well as the PET scan. Then it will try to actually identify whether the cancer is there or not with respect to the lungs. Then we are also working with emotional intelligence with respect to the neuro images. So our objective is to build a multi-model classification which will actually accommodate more than one heterogeneous data. So the current scenario is actually when you look at in the machine learning field, we have a model or we have a diagnostic things which is happening with respect to each and every diseases or maybe for one particular data, but there is no one model which is actually used to facilitate. I think a lot of disturbance, sir. Can you mute all people if you don't mind?
Yes, madam. I will mute.
Yeah.
Ma'am, screen is not visible.
Is it?
A screen
Okay.
is visible, madam. Please proceed. It is visible for all.
Maybe internet issue is there
Issues
with
are
the receiver. Yeah, I think my screen is visible. Means thank you,
visible,
sir.
but
Thank
it is in the first slide, madam. Good afternoon slide. That's right.
Yes, yes. Still, I am there in the good
Yes,
afternoon
yes,
slide only.
yes.
I just wanted to brief what is the journey I'm doing it with machine learning. Then I thought I will proceed. So today, what I planned is actually it is for two-dimensional image classification to the three-dimensional image classification with respect to medical diagnostic. One of our research is actually a predictive model for cardiac arrest. The another one is the respiratory movement in lung tumor. The third one is recent scenario is we are trying to develop a multi-model development. So I thought I will start with the 2D image classification to 3D image. I'll be giving the link also for you people to, take it further to do the demo, because initially people started using a deep learning model, but now in the evolution of machine learning, when we see artificial intelligence is there, everything is under the umbrella of artificial intelligence. But now when we see recent scenario is machine learning, then now it is a deep learning model. So how efficiently we can apply machine learning method to classify 2D image as well as to classify 3D image. That's what I wanted to conclude. I may be just running through my slide and explaining. Yes. I hope it is no problem. So first research work in machine learning is we worked with the
Madam Chandra, madam, please unmute yourself.
Voice is not audible.
Chandra, madam, please unmute yourself once, please.
muting all. I am also muted. Is it
Yes,
audible?
You're audible, madam, please.
Fine, sir. Fine. Screen is there, visible?
Yes, madam,
Is
your
it
screen is
visible?
visible.
Okay, fine, sir. So this is the cardiac arrhythmia, where the early prediction of sudden cardiac arrest. The first thing is actually the normal heart, and the second one is the abnormal heart. What is our work is with respect to cardiac arrhythmia? Why this arrhythmia occurs? As and when we delay the treatment for the heart attack patient, arrhythmia will occur. But our work is actually concentrated on the decision making of whether to fix the pacemaker or not. So, according to WHO in 2015 itself, the heart disease is the number one case of death based on the survey disease. But we were actually worried about the pandemic and other things. But after pandemic, the scenario is changed. But post pandemic problem is there.
Ma'am, it's not audible.
We also actually validated with respect to the clinical heart. So early prediction helps the doctor. It is a kind of a assistant for the doctors to predict whether the patient is need of pacemaker or not. We call it as ICD. So let me brief about why ML and how ML is used in medical image processing. As you all know, we have different kind of tools are available clinically to test. So as and when we go to doctor, they say you go for a EEG, ECG, CT scan, PET scan, MRI image, fMRI image, neuro image, and physiological signals, microscopic image, dermatoscopic image. These are all actually variety of images are there with respect to medical field. But sometimes doctors are not in a position to understand what kind of image it is, where the you know uh, the affection has happened, whether maybe if it is a cancer or if it is a tissue where it has happened, it may not be very clear also. So they need of actually some kind of an intelligence tool people are looking for. So that's where actually machine learning is used to develop a intelligent technique. So in medical imaging has become an essential component for many of the biomedical research as well as the clinical practice. So in medical image processing, we analyze, visualize, and which enables the quantitative analysis and the visualization of the medical image. Numerous modalities are there. For example, one is the PET and MRI, CT, and microscopic. So each one we say one modality. The analyzing, we used only the MRI modalities. The analysis of these kind of a diverse types of images, it requires a very sophisticated and computerized quantification of the visualized tool. That's where actually we developed a hybrid method. I thought I will just show our model, then go into how we did actually two different kind of modalities and fusioning, then pre-processing and the classification. Hope all of you might have heard about the pre-processing in machine learning. Yes, madam. Pre-processing is actually, it is nothing but an essential component for the data analysis field. Why I need to talk about pre-processing means the moment we think about data, the real world data is a dirty data. We need to actually remove that dirtiness, because the way in which we collect the data and we process the data, it becomes a lot of complexity is there. So, but there is no compromise on the decision making process, because our ML will give a diagnostic. The inference is based on what the machine learning model will give. So before we go for applying a machine learning or artificial intelligence or deep learning model, we do a lot of tasks. The first task is actually, it is a pre-processing task, which is used to reduce the complexity. Why we need to reduce the complexity means, which will actually further improvise the accuracy of the machine learning classification. But the most pre-processing is, I think it is echoing. Somebody switched on the mic or something. Is it
Yes,
okay
ma'am.
now?
You have muted, madam. Please proceed, please.
Yeah, yeah. Thank you, thank you, sir. Most pre-processing is used to reduce the noise. Noise is nothing but unwanted things in the image that should be identified and removed, so that we will get the quality output or the outcome, which can be the increased accuracy. So reconstruct the images. Maybe sometimes we will enhance the medical image features by using the pre-processing techniques, which plays an important role. The main aim of the pre-processing is to improvise the quality of the image and suppress the unwilling distortions to enhance the features. So segmentation is considered as one of the pre-processing tasks, which is a very, very popular method and an efficient techniques in the context of the medical image analysis. So the segmentation process is to label each pixel in the image and locate the boundaries and the objects. So propose the segmentation. I have actually underwent conventional neural networks method is considered as one of the very good segmentation method to uh, segment the contour of the medical images. But I will be talking about few literature which I have come across, because given a scenario I had given only 1 hour time, so I will just share my experience whatever we did with respect to two different cases of the healthcare. Feature selection method. The feature selection method is an essential method which is used to reduce the dimensionality reduction. As we all know, the high dimensionality of the data, which will take longer time, and accuracy also will be very, very less. So to avoid that things, we need to actually reduce the dimensions, so that the data transformations becomes very efficient process, removing an unimportant problem actually, which gives a better accuracy in the predictor field. So feature selections, which actually considers one of the important predictor task, as well as the feature extraction. When we consider the original image of the reduced number of features, including the discriminatory informations, the data dimensionality as well as the reduced redundancy are irrelevant information, which further transforms in the form of an appropriate classification, which yields the improvisation of the classification performance as well as more stable representation. So if the bandwidth of the input data is reduced, improving the processing speed is actually, it is more possible. So simply extraction method, which are mainly based on the data reduction to obtain the scalar features, and later comes into the classification. So image classification is based on the clinical study. It is a visible issues which aims for classifying and medical images in various categories. So which is the key point of a computer aided diagnosis system in the field of a medical image classification. So this is one of the important problems in the image recognition area, as well as aims to classify the medical images into different categories, which further helps the doctors in decision making process or for the further research. So to name a few existing methods, I have actually done few literatures, so that I'll be sharing with you people. So generally, the common method for the image enhancement is the histogram equalization, which enhances the contrast of the image by doing the equal distribution of the gray level. So to improve the performance, different generalization have been implemented. Combination of the histogram equalization and wavelet transformation, which is actually considered as the improved performance on the ultrasound image. This we come across during our literature. This is actually with respect to the abdominal walls for real-time performance in the dynamic applications. Another literature which was talking about the morphological filtering, which is used for sharpening the medical images, so that to sharpen the existing image after applying the gradient based operators, which will actually either increase or decrease the color in different parts of the medical image, which plays a major role in the pre-processing techniques. Another thing is actually morphological gradient for locating the edges in the image. So one of the best comparable result is actually as a Sobel and Canny. This is a medical terminology. Investigation based four methods as image smoothening, phantom corrections, surface fitting, and homomorphic filtering. These are all actually performed with respect to the images. So fuzzy C means method is actually considered as one of the popular segmentation medical images. Improved fuzzy segmentation also we found, that is for the local spatial as well as the classical clustering methods. And kernel method also we come across, as well as the Wotso techniques was proposed by Wotso in 1979. And Wotso is considered as the global thresholding selections, which is used for simple and effective way. This is actually considered to be a fast recursive techniques which reduces the computational time. Wotso technique is one of the best techniques for the real world images, which is based on the shape and the uniformity. And another few methods what we come across, just I'm giving a summary, or maybe you can consider it as a findings from many literature. For doing the segmentation, because segmentation is considered as one of the very important task in the medical image processing. This is considered as the pre-processing technique, so that we can tap the locations where you want to process your data. The heart image, maybe the whole image, we are not trying to use it for the heart attack, or maybe for the tumor prediction. The tumor may be occurred in one particular portion of the area. That area should be identified and it should be extracted from that whole image. So for that, the important task is actually segmentation. There are various machine learning algorithms are there, but what we found is median filtering, Gaussian filtering, fuzzy C means, edge detection, region growing, support vector machine, it is calling it as the SVM. These are all actually gives the better result while applying the segmentation process. We also actually used a hybrid model, because we proposed a hybrid model for medical image pre-processing to increase the accuracy of our classification. Classification, what we used is a neural networks, deep neural networks, and decision tree, K means. These are all some of the machine learning methods. But we proposed a hybrid model for the medical image processing, which is considered as the increased accuracy on our predictions. We also actually given the name for that particular predictor model. It is called it as IAAP. Nowhere actually we actually publicized or patented. It is proposed but published based on this particular model, one articles. So this model is called it as the intelligent analytical arrhythmia predictor, because mainly this is used as the arrhythmia predictor model to contribute in the terms of early predictions of the high risk arrhythmia patient, which could used to avoid unnecessary implantation of the pacemaker, or you call it as the ICD. So generally medical techniques are used by the radiologist to visualize as well as to identify the scared region in the myocardial infarction patient for the prediction of the arrhythmia patient. So this case one is I am talking about the sudden cardiac arrest, which will occur for the heart attack patient. Generally, when we delay the treatment for the heart attack patient, and myocardial tissue will occur inside the heart, that becomes the problem. Then breathing becomes problematic. So over a period, then it leads to death. So to address these things, actually, our study is based on the machine learning method, which addresses the clinical needs. The current approach automates the identification and the classification of the scar region in the heart for the prediction of the arrhythmia. Based on that, we categorized also whether the scar is very less or maybe more, depending on the volume. The volume also we used a machine learning method to calculate the volume, and then based on that we categorized. So this is just to know about the domain knowledge, because you may be thinking, ma'am is talking about a lot of medical terminologies. As you all know that I believe in doing a real-time research, because we always consult with the concerned people to understand about the particular domain. So when we are trying to do it for the myocardial infarction, We have done a lot of training on that. So it is called it as the ischemic cardiomyopathy, that is shortly called it as CM. So this is actually, you might have seen left ventricle to obtain the two-chamber view. And 1 second, let me take the highlighter laser pen. So that this is actually a myocardial infarction. This one is the tissue is forming as and when we delay the patient. That's why actually we try to give the treatment for the heart patient once they are suffering. So we rush to the hospital, or we will try to do first aid, and then we will go for a treatment. We should not delay it. This is, as we all know. So this is actually four type of the myocardial tissue. See, this is the excuse me. It is not visible. So I hope the screen is visible. I am not. I am changing my screen. Delayed
Yes,
enhancement
ma'am.
of
Your screen
myocardial
is
tissue.
visible, please.
Fine, sir. Thank you so much, sir. So this is the heart tissue. So this is heart attack occurs if it is in 15. This is a simulated information actually. What I am showing, because only the layman point of view we can understand only this. So this is actually call it as the white patches 15. There was no tissue. It is there. This is actually called, the red portion is called non-ischemia. This pink portion is called ischemic. Yes, it is a viable. But when we delay it, suppose in case approximately 40 minutes when we delay, the yellow portion is actually called the myocardial tissue will occur. As and when you delay more, the more things will occur. So it is for roughly the 3 hours. It will actually spread across the various places in the heart. Greater than 6 hours, you see almost it is going to block that, the ischemic viability, so that the patient will die if they are going in this particular direction. So what is our role is actually, we found these tissues and volume calculation. We understood that the radiologist, they were actually doing it manually with respect to these particular tissues. But we automated this process by applying the machine learning method. So this is the first stage when heart attack occur. This is the second stage. So no tissue is there. This is the fourth stage, more than 6 hours. So first stage and the fourth stage, no need of fixing the pacemaker to regulate the heart. So let me brief what is called pacemaker or ICD. We generally call it as the pacemaker or ICD to regulate the heartbeat, so that our functionality will become normal. When the heart patient actually, if we delay the treatment, the tissue will occur in the region of the heart itself, that it is called it as the myocardial tissue. This is the yellow portion is the myocardial tissue. This is with respect to 40 minutes. If we delay, for 3 hours, it will spread across. If we delay more than that, it will be actually more it is there. So this first stage and the fourth stage, there won't be any decision, no need of fixing ICD. But if the patient is suffering with in between stage, then our model will recommend that we can actually fix the ICD to regulate the heart. This is actually the delayed enhancement of, sorry, I think people are talking in between. This is the delayed enhancement of the myocardial tissue. So this is actually the medical point of view, how the tissue will look like. The previous one is the simulated one. The current one is actually the white patches in the heart. This one, I think people can view that, right? This is actually called myocardial tissue, and it is very very essential for us to understand and measure how much severe it is. Depending on that, the doctor will actually take the decision whether to fix the pacemaker inside the heart or not, because unnecessarily implantation leads to a lot of complications and the negativity for the human body. So as they were actually approximately doing the volume calculation and other things, we thought actually we can try to regulate the particular problem. So that was the motivation. Personally, my father actually died with a sudden cardiac arrest because we did not know. So heart functionality stopped while sleeping itself. This is once in, I think, thousands of people will get this kind of a things. This is our model. In the framework, what we did is actually we developed a hybrid model for the segmentation, that is in the form of a morphological filtering plus fuzzy k-means, comparing with the literature. And in feature selection and the feature extraction, we used gray thresholding and region growing. And then volume finding, we used a flat fill algorithm for calculating the volume of the tissue. This is the volume of the tissue, the white patches, that we actually used automated with the help of the flat fill. Then later we apply that particular value measurement is gone into the ML algorithm decision tree. Decision tree we use for making the classification. Maybe people may think, why decision tree? Why not deep learning or CNN or RNN? Because these are all actually the latest scenario for the classification. As you all know, the decision tree is very, very popular for making the decisions and especially for the binary classification. So our work is actually whether we need to fix the LCD, ICD or not. So that was the motivation. We also used LSTM, also used the CNN and SVM and compared with other machine learning model, but decision tree gives the higher accuracy. So that myocardial dyspnea is the class 1. In the first stage, there is no yellow patches. This is the second stage, 26% to 50%. That is there in the 45 minutes if we are delaying the heart patient. If we are delaying more than 6 hours, it will leads to 51% to 75%. This is actually when we delay more than that, then it is class 4 category. So this is actually, it is categorize our ML model, use it to classify and categorize whether this patient belongs to class 1 or class 2 or class 3, class 4. So depending on that, the recommendation will come from the model. So the recommendation will come only from the in-between model. That is nothing but class 2 and class 3. If the patient belongs to first category and fourth category, we will be getting no need of fixing the ICD. That also we verified and validated with respect to another machine learning model that is called Levenberg-Marquardt feed-forward neural networks. That is called it as the LM feed-forward neural networks. This is in the testing model. Okay, so we have actually did the pre-processing, we did the feature selection and the extractions by using the gray thresholding and region growing. Then we used volume finding for the heart tissue with the help of blood fill. Then later we actually loaded our volume to the classification and prediction. That is with respect to the decision tree. Then we categorized whether it belongs to class 1 or 2 or 3. That also volume is mentioned here for your reference. In this afterwards, finally, the layman point of view, either the doctor or the family people need to take a decision whether we need to fix the ICD or not. The ICD is nothing but pacemaker or not, because it is not actually very less price. It is more than a lakh. So as well as not only for the cost, then for also for the health of the patient. See, we won't actually recommend for any kind of an external material can be implanted into the human body that gives a lot of negativity. Most of our living populations are middle class family. They may not afford to even go for an MRI scanning or maybe for treatment of this heart attack. So if it comes, if the doctor says you need to actually fix the pacemaker for normal people or maybe for the average income or salaried people, then unnecessarily they'll be spending more money. So that was actually the social impact what our model is actually trying to rectify. We used open data repository, that is call it as the cardiac atlas from Sunnybrook cardiac data. We also used one data called the MICAI data set. So we tested with the two different data set and perfectly it was working. I'll be briefing slightly about the model because considering the time given for me. So median filtering, I told I used for reducing the noise in the MRI image. As you all know, this is a very simple step. I'm not going for explanation about the median filtering. Median filtering is mainly used to reduce the noise, and morphological filtering also we used to identify the contour with the image enhancement. So mainly this is morphological filtering is used to enhance the image, and these are all the methods what we used for the morphological filtering. And we used a fuzzy scene means to segment that particular contour. This is actually for the identification of the contour. We use the morphological filtering. To segment that particular contact, we use the FCM. That is nothing but the fuzzy C means algorithms. We used a gray thresholding to separate the foreground and the background of the image. You may be thinking why we need to actually separate this foreground and background. See, we try to consider certain necessary features for our analysis. Most of the times, foreground will be an unnecessary component, or we say it is the noise. So that time we need to actually separate that foreground as well as the background. That's where actually we used gray thresholding method. That is a very popular method for eliminating this things. Then we used only the foreground to do that car volume distribution. We applied a region growing algorithm to extract the particular scar, and we went for the decision tree to classify the data based on the scar volume comes under class 1 or class 2 or class 3 or class 4. Depending on that, we try to actually identify the noise in the MRI. So noise identification is done with respect to speckle noise, Gaussian noise, salt and pepper noise, and Poisson noise. These are all generally different kind of noise which will be there in the medical images, especially which found in the MRI image. Now we need to identify, is there any method to remove that particular things? So whatever we did is actually, first of all, we need to measure, and also we need to categorize which kind of a noise it is. So based on the histogram equalization, we measured the noise as well as we identified what kind of a noise it is. And the noise is calculated based on the signal to noise ratio, that is considered as the PSNR. So look at the right hand image visualization. This is our original image, and this is for the patient number 1. We worked for around 150 patient. This is the histogram image which shows the noise. See, I'll share my experience why I use the histogram equalization means. In that open data repository, they mentioned it is a pre-processed data. What we assumed is actually, we thought noise is removed, everything is processed, we can straight away use it for feature selection, feature extraction, and segmentation, then go for the classification. So we went till classification, we came back like recurrent neural networks, because that is actually the current scenario, learning from the past mistake. So what we found is actually, even though we got some kind of a highest accuracy, but experts suggested that why don't you measure and cross verify, is there really any noise is there or not? Then we understood that some kind of a noise which is very, very less, even though this is considered 0.5 percentage, but that is also a meaningful noise. So we need to actually identify and remove that. So after applying the histogram image before noise removal, it was like this. Then when we removed the noise, the image shape is actually, it is like this. But as a layman, we cannot identify what is the difference between the removed image as well as without removal. But only we can use the mathematical visualization tool to identify how much it is removed. So look at here, before the removal, it was a huge portion was there, histogram. Here, so much is eliminated. This is only 0.005 percentage it is existing. Is very, very near to 0. So this is our verification for the noise removal as well as validation of whether the noise is really removed or not. So this is for the another patient. Originally noise is there. Then after removal of the noise, so much is removed, because medical field you cannot identify whether the noise is removed or occur. So look at here, this there is a white patches which is there. This is call it as the scar. But that scar should be categorized whether it belongs to class 1, 2, or 3, or 4. Based on that, the recommendation will come from the model. Assuming that it is belonging to the third category, the model will say that need of ICD. If the volume is very, very less, then it will say that no need of pacemaker fixing. But then we did a lot of process like this. This is actually the original image, which is respect to the third patient. Why I'm showing all these kind of images means, in the body, we have actually different kind of movement is there with respect to the heart. So I think maybe if possible, I will try to open the video and show at the end. So closing stage as well as in the middle stage and the end stage. Now end stage, it is very, very difficult to measure. That will be highlighted in the form of a sagittal view. So these are all actually various sample while applying the median filtering and segmentation with respect to the morphological filtering. This is after the removal and before the removal. Now, now I'm showing that the original image is looking like this. After applying the Gaussian blur, the brightness you could see how much it is improved. Then bilateral filter we applied, then mean filtering we applied. median plus morphological filtering. So each and every method, the very popular method, we tried with this many method, but the last one is actually our proposed method. We proposed median and morphological filtering is necessary for, and that it is compared with the other popular methods called Gaussian blur and bilateral and median filtering, all those things. This gives the very good impact with respect to the individual algorithms. So the second step is actually the segmentation using fuzzy C-means. So in segmentation, we made cluster 1, cluster 2, cluster 3. We used median filtered image to the fuzzy C-means that we worked for all 3 patients. And then what we found, you can compare, this is a compared result. We used efficient Warshett method, morphological gradient, histogram equalization, edge detection, then the fuzzy C-means. But what we found with all 5 columns, fuzzy, fuzzy C-means is actually, it is compared with the more efficient for the segmentation compared to the other things. So we have taken FCM as one of the segmentation method. Then we did gray thresholding, that also we measured, and then we actually separated the tissue. I think I had shown the yellow patches and the white patches in the simulated image. This is the originally how it is after segregating the scar volume using the feature extraction and the region growing. So the scar volume for 3 different patients, it is looking like this. The first patient is actually the bottom of the thing is very, very less, mild. So that no need of actually facing going for fixing the ICD. For the second and third, you see the volume is actually, it is more. So what the model says, we need to actually fix the ICD. So that is the conclusion which is given from the model. We also verified with the cardiologist to cross verify the radiologist report is correct, because ultimately the cardiac related problem, radiologist will only give the report, but the cardiologist will give the recommendation. So our work is actually in between the cardiologist and the radiologist, but mainly to supplement the assisting tool for the radiologist, which we automated that particular things using the machine learning method. So another thing is the flood fill algorithms. These are all the calculation how flood fill algorithm is working to calculate the height and the width and the length of the particular scar. So it is measured and displayed also. I'll be rushing it a little bit because considering the time, another 20 minutes is there. I thought I will explain another one. So here, classification and the prediction for the first patient. The left side is actually, it is original. The right side is actually, it is considered as the medical value. That is nothing but the ground truth value. So almost it look like same, the shape, the width. So here we say it is no need of fixing the ICD. This is the ground truth value, and this is the original extracted tissue. And here also no treatment. But in the third case, when we compared comparison, here also no need of ICD. Comparison of proposed method as well as the ground truth value. This is the proposed method result. This is the radiologist what they suggested. Everything is almost the same, but the time taken to measure and analyze by the radiologist, it is actually more than 1 hour. But our model, we worked with respect to 2 to 3 minutes. So we actually reduce the time, we reduce the complexity, we actually improvise the accuracy as well as the diagnostic, which will not actually recommend for wrong diagnostic, which will give a correct prediction whether to fix the pacemaker or not. We also verified with respect to matrix evaluation we did for all 3 patients. The bin values we displayed. Then this is the final result. So we also worked for normal heart. Maybe you may be thinking, madam is actually showing patient 1, patient 2, patient 3. That is patient 1, 2, and 3 is an affected patient. This is with respect to the normal heart, how the model is working. You look at the final result. There is no tissue found here because everything is look like a blank. Because this is a normal heart. This is a median filtering. After applying morphological filtering and all these process FCM, then we got actually the emptiness. So it means the normal heart, it will not say that the tissue is occurred. So normal heart also we checked and verified. Excuse me. Yeah, any doubt or any clarification? Can you
No, madam, I
mute your
think.
Madam.
I will just unmute. Proceed, madam, please.
Ma'am, please unmute yourself. Ma'am, it's not audible. Please unmute yourself. Ma'am. Dr. Chandra, ma'am.
I'm not audible, ma'am.
Ma'am, it's not
Please.
audible. Please unmute yourself.
Ma'am, not audible, ma'am.
Ma'am, it's not audible. Please unmute yourself, ma'am.
Yeah. I hope now I'm audible.
Yes,
Thank you.
Yes.
Thanks for the feedback. Hello. I think individually people can mute yourself because in between lot of disturbance are coming. So that if we are muting, then everybody will be muted, including me. I hope I'm audible.
Yes, madam, you are audible, please.
Yeah. Elapsed time it is actually it has taken 3 seconds we can say, but originally 20 minutes. Maybe wondering how we actually measured this. We sat with radiologists to measure how long they are taking for each and every patient. So average we have taken 20 minutes actually they are taking it for measuring that particular patient. But in our model it is only
Ma'am, again. Ma'am, please unmute it, ma'am. Ma'am, it's not audible. Please unmute it. Ma'am, it's not audible, ma'am. Ma'am, it's not audible, ma'am. Please unmute yourself.
Ma'am, your voice is not audible, ma'am.
people muted me. I'm sorry for this. I request individually all of you to mute yourself so that there won't be any noise or disturbance. Am I audible right now?
Yes, madam, you are audible.
Yeah, I'm sorry because unknowingly we are trying to mute ourselves because of intermediate disturbance. So we apply the KNN. These are all, yes, sir.
Actually, we have to
Yes,
tell
sir.
you sorry. Actually, we are sorry for that. Actually, please.
No, sir, it's okay. Online difficulties are there. Thank you all for the kind cooperation. I'm really sorry because unknowingly I'm speaking. Sometimes it was muted. Thank you so much for the positive response. So we have used the KNN method for the confusion matrix to categorize and found. And most of our false prediction rate is very less. When you see here, false discovery is 40 percentage, but positive prediction is 60 percentage. So this is a wrong categorization which is not there. So look at the decision tree. Decision tree we found false discovery is only 4 percentage, but positive prediction rate is 96 percentage. We used MATLAB for doing all these things because it is an MRI image. A recent scenario is people can use Python tool, OpenCV because a lot of packages are available. We just have to import and use it. But I may say that still image processing and video analytics, image analytics, MATLAB is actually an efficient tool. And since Python is growing like anything every day, we may not get that much sufficient information from that. But one is going for the production based tool development, then we can think about MATLAB. Otherwise, the conceptual innovations, we can always use the MATLAB for video analytics and the image analytics. But the simplification is Python, but efficiency with respect to implementation, I can say MATLAB. So each and every tool has its own advantages and the disadvantages. So performance evaluations we carried out with respect to SPM, KNN, and decision tree. The error rate is actually measured and displayed here, 0.4 percentage, and KNN is 0.1 percentage. But look at the decision tree, it is 0.03. It means almost it is equal to or maybe near to zero. So we consider decision tree as one of the highest accuracy for making the prediction. So what is the prediction we did? We actually evaluated the heart and found the categorization. Based on the categorization, we say whether the patient need to be implanted with ICD or not. That is our the work. So we also used feed forward neural network as the referential classification, and we measured these things. I request you people to mute yourself. Sorry, because I think only 10 more minutes I have to explain one more model. So this is actually the model verification with respect to the feed forward neural networks. At least the outcome of the session is people can understand how the model is behaving with respect to MRI image and CT scan and PET scan, so that many of you may be expert in image processing and medical processing. So commonly or maybe collectively we can collaborate and work also. So we can understand these are all the methods in the machine learning field, which is trying to give a solution for the real-time problem. So we use the histogram again to measure the error rate. Then we found which is reducing so many bins, because what is meant by bins? Because anyhow, when we are working with images, we will be working with matrix. But after doing noise reduction, we found the bins are reduced. So that was again, it is visualized and represented also. We plotted a regression plot, and the neural networks, the training fit is shown how far the model is actually fit into the range. So the model curve is also represented. This is the linear regression. So it is approximately or accurately. So you see, this method is actually giving a very accurate prediction, we can say, because the regression plot is plotting very accurately. So now this is our performance graph with respect to 4 phases. What we did is we did median filtering for filtering the particular things,
सर
morphological
आपको
filtering
कुछ
at the
पता है
FCM for
कि जोन से
doing
कैंडिडेट
image
का
analysis.
प्रोफाइल एंकरिंग में हो, एक्टिंग में हो, उनको यहाँ कोई है जॉब?
So we have actually enhanced the image with respect to these two hybrid method. Great. I hope I'm not muted.
Yes, madam, you're audible, please.
Yeah. Thank you, sir. Sorry, sir, asking again and again. In phase 3, we actually extracted the tissue from the heart, because all these background and the whole uh, area of the heart is not needed for us. Our aim is to focus only on whether the tissue is found inside the heart or not. So that we extracted the tissue using gray thresholding and region growing. And this is actually using the Fletcher algorithm. We calculated this volume of this particular tissue. So when you look at here, this need ICD because this belongs to the third category or the second category, but this is no need of ICD. This also no need of ICD. That is what the decision tree algorithm is giving. So now let me take the laser pen. So you look at here, this the tissue is extracted. After the extraction, we used this tissue in the decision tree classification. The algorithm is actually giving a suggestions that whether we need to go for ICD or not. So look at here. I think this is an animated image. This is call it as the systole. Why it is systole means it is a closing stage of the heart. It will close and open. It will close and open as and when we breathe, right? So when it is closing, how to identify the tissue inside the closed heart? That was actually a lot of challenges for the doctors. Even taking the MRI also because shadow will occur. Breathing organs becomes a lot of difficulties are there to take MRI as well as to diagnose. That is why we have taken lungs as well as the heart. These two are neighbors and a lot of risk is there to identify and diagnose. So in this systole, even while we are testing it, we worked with the two different patient for the sample. I'm showing it. In this, you see the tissue is extracted and this is implanted, and again it is checked whether it is needed ICD or not based on the value. These are all some of the statistical method. These are all actually the model, our model I have given here. So the outcome of this particular IAAP, that is a machine learning model, intelligent arrhythmia analyzer, we had given name like that. Myocardial infarction disease is one of the most predominant death in the worldwide. Early detection of the scar in myocardial could potentially prevent the arrhythmia. So early arrhythmia prediction, this is actually we use the hybrid model. In that hybrid model, referential classifier, we use this LM neural networks, that is Levenberg Marquardt neural networks, which portrayed 99.5% of the accuracy. The result indicated the early prediction of the arrhythmia patient, which has been conducted with respect to all kind of 5 stages, measuring the volume of scar in myocardial infarction. Why I named it as 5 stages means even we worked with normal heart as well as with the affected heart patient. That is including that it is the 5 stage. So no heart related things, and if at all if it is affected, then it is 4 stage: class 1, class 2, class 3, class 4. Diagnostic tool we just only developed using ML. We have not actually developed software for that. Using this in future, we may try to develop you know mobile applications or maybe web application, which can be a helping hand for the doctors. We also verified with the doctors in India as well as in USA. They were really happy with the work. So that is why the scholar is actually doing postdoc in medical university itself in the cardiovascular department. So I can proudly say I should thank her for her hard work. One more research work which machine learning model we applied is respiratory motion identification for the lung cancer using PET as well as the CT. Maybe you people may be thinking why this ma'am is working with the PET, CT, and all doctors can identify why machine learning. See, the problem is the breathing induced motion of lung tumor leading lot of gases which is there, which affects the radiotherapy planning and treatment delivery. Radiotherapy planning means one who is suffering with the cancer will suffer like anything. So in this respiratory movement, the tumor makes very, very difficult for the accuracy of the treatment delivery. So this is actually the motivation for me to think about this lung tumor. But why two different image, two different modalities with respect to one particular disease? Now, recent scenario in the medical field is average people will take EEG, ECG, fMRI, MRI, all those things, depending on the diseases, so that they will cross verify with respect to one stage to the another stage. Then based on that, they will give the treatment. Now, is there any model? Is there any method which is available to identify the correct diagnosis? If I say maybe 10% or 20%, more than one combination, people used. Now, the reason scenario is people started using a hybrid method, multi-model development and all. It is a recent happenings in the healthcare industry. So the radiotherapy is actually gated radiotherapy is undertaken to identify the motion and to deliver the radiations to damage the tumor tissue. So, however, the issue is the manual intervention during the procedure. We cross-verified, it is not the theoretical knowledge. We cross-verified with the nuclear medicine people because our work is actually a supplementary or maybe a helping hand for the nuclear medicine people. So it is a physiological reactions and even radiation toxicity in the cancer patient. So radiation arises when high dose of radiation is passed on its short time interval. But when we normally do this kind of radiations in the wrong place, it is really hectic things which will affect the patient like anything. So accurately, we need to identify which portions cancer is there. Based on that, it should be actually treatment should be uh, happening like that. But since it is a respiratory movement, I will show you how this respiration is happening. Can you people see here? This is a lung tumor during radiation. If you try to take radiation, the tumor portion is getting moved here and there. So now how do we make the treatment? Wrongly, see, if the tumor is moving up, then we consider the tumor is moving up, we consider the radiation is actually trying to happen here, but actually it is down. So to avoid that particular things, we use the machine learning method to identify the contour of the correct place. So this is actually the manual fusion. Let me explain what is meant by image fusion. Image fusion is, I will take 2-3 minutes. Do I have time, sir? Can I take 2-3 minutes? Kiran sir or somebody can respond.
Yes, ma'am, please.
Yeah,
Please,
yeah. I'll just wind up within 2-3 minutes. So, see the outlook of the manual fusion. People used CT scan and PET image, PET, we call it as a PET image. Manually, they combine those two and it will give a blurred image kind of things. So there is a need of actually combining these two images. So we applied a lot of algorithms. So we eliminated this manual fusion because those who knows image processing, you people may be knowing that image fusion is actually one of the fusion for the hybrid images, especially when we are trying to use MRI, fMRI, EEG, ECG, all those things. Multiple data with one solution, it is possible we need to actually fuse that. But while doing fusioning also, there may be a lot of noise will be there. These are all some of the examples what I thought I will share it with you people. And then skipping certain things, we used conventional neural networks and we got 99.29. And we also used watershed method for the segmentation, also thresholding. These three are used for the segmentation method. Previously, when you see, I was talking about some other method for the segmentation. But since the modalities are different and disease also it is different, because the segmentation techniques also which will vary. So we cannot generalize the machine learning method. This method is very, very popular. Use always conventional neural networks for segmentation. If I try to say, I may be wrongly guiding you people to use a CNN method for the segmentation because it will vary from one application to the another application. And also depending on the brightness and the color, the features, the problems, the complexity, etc., etc. So now this is the real appearance of PET image, original image, background subtraction. So background is removed. Conversion to black and white after removing the background. Then distance transformation to find out the non-zero values. We applied this. Then this is a simulated things using segmentation using watershed method. And we also used Warshaw thresholding because Warshaw thresholding is considered as one of the very best method you might have heard about in the previous case also. Using this, we did the segmentation. And this is with respect to CT image. We measured the noise using the histogram. You see the pixel intensity is measured with respect to the noise that is displayed here. We also used linear filtering, which is actually to correct as well as the blurred image becomes little things, including the motion blur. So noise is removed using Doppler as well as the linear. and experimental result is actually, it is displayed here. Then this is experimental result. We use the point transformation. Look at here, these are all actually the artifacts. So there are so many artifacts we identified. We did research on the image artifacts, but we found a lot of clinical papers because doctors are facing problems with respect to the artifacts. The artifacts is nothing but when we take the scanning with respect to our dress, the buttons, or maybe the clips or the external component, pillow or bed, all these things are actually will be a part of the component inside the CT scan image. That becomes a disturbance for the diagnostics process. So that should be identified and removed. So that we did, and as I mentioned already, histogram equalization is one of the very good algorithms. I can say we can use it for multiple purpose. Previous type we used for measuring the noise. Here I used as the contrast improvement. So after improving the contrast, we also measured the noise and displayed it here. So much it is actually, it is improvised. Contrast is like this. Error is improvised. Then spatial filtering we have done. Smoothing also we did. And we used median filter for the experimental, that is visualized here. This is a salt and pepper. And then morphological operations we applied. That is for the experimental result is carried out. We use the contrast enhancement, linear filtering, and Doppler and linear filtering is used, histogram equalization. You may be wondering, this is all PET images. It's very difficult. This is the original image. What we did after applying this contrast, we changed like this. Then we used the histogram equalization. It becomes like this. These are all different stage you can see. So enhancement we did, and we also measured. So you can see this portion is the tumor portion, which is viable and visible after doing the enhancement. So now currently we are actually trying to categorize the portion of the particular cancer because a lot of disturbance for the respiratory. So we are using a deep learning method for doing that. So this is again noise removal and other problem areas. And I'm skipping here because of the time constraint. All of you may be knowing about image subtraction. So simple image subtractions will improvise the background, improved background you could see. Wavelet transformation method also we used. This is one of the famous things. And again, when we did research on the artifacts, we wrote a paper on the artifacts survival and ring artifacts and fused image misinterpretation of the artifacts. And we used the PSNR value to measure the noise ratio, structural similarity also. That is displayed here. And that is also, it is represented. I'll go to the 3D image classification. We have done one copyright for the image fusion, and this intermediate result is published in the Frontier Medical Technology. That is one of the very popular clinical journals. So these are all actually whatever we did fusioning with respect to PET and CT combination. We applied Fourier transformation and wavelet transformation for horizontal and vertical diagnosis. Yes, sir.
मेरे से देखिए मेरे को लोड दिया थी मेरे
Is it people are talking to me?
No, madam. Accidentally they are unmuted.
Okay, fine, sir. Am I audible, sir? I will just give a conclusion.
You're audible.
Yeah. So I'm sorry for the extension. Multi-classification versus multi-label. Multi-classification is actually, it is very essential because when we are trying to classify more than one, but with respect to single modality. But when we are working with multinomial or maybe with multi-labeled classification, how far machine learning is actually, it is used to categorize. So that is a recent research wherein which we need to think about doing a lot of research on that. Multi-model classification is more than one data and multiple modalities. So this is one paper what we referred here. They are using the audio, video, textual features are there, and which is shown here, multi-model architecture. This is for the education segment. They are categorizing how far the video is very efficient, text, audio, visual. So 3 different things they used with respect to deep learning method for the segmentation. This is a real research problem is single modality with multiple data types, multiple modality with multiple data or the single data. How we can use and compromise. I found that there are two papers which is a very good papers from the Stanford University, multimodal deep learning, which is there in the research gate. This will come as the topmost. Multimodal text and the image classification. And these are all some of the references. And this is a 3D image classification from the CT scan. I will show you. This is scan which is worked for 3D image. Thank you all. 1 second. Before I ask for question, I will show you. This is the 3D image. This one, I think I can give it in the chat window. I hope chat window is available.
Hello, good evening, ma'am. Excuse me.
Yes, sir. Yes, madam.
Yes, ma'am. Actually, I'm not able to mark the attendance. Link is not active.
See, that will
Oh,
take
you
up.
have to ask the
Let
organizer.
the session will be completed. Yeah.
Once this, yeah. Let me complete, madam. Sorry.
Yes, please.
Okay,
I think I'm not able to give the chat, sir. Chat is also muted, I think. Maybe. The link. This one, it is visible, right? This is actually when you put 3D image classification from CT scan. Now, the Keras platform, machine learning, is actually, it is launched. This is the recent things what I talked about Stanford University paper. PyTorch and PyPy is the recent one in the Python. And we can try to refer, you people can refer this sample. It is worked with training, validation, testing, all those things with respect to CT scan. This is a post-COVID lungs related problem, pneumonia problem classification. This is around 150 patient details are there. Very nice predictions, whatever which is given here. Deep learning model. How deep learning model is actually it's worked for 3D classification. So 3D image classification from the CT scan. So why I am showing this? So I especially concentrate for the image classification. Now, given a scenario, whether it is a 2D image or 3D image, now 3D CNN are very powerful model for learning representation for the volumetric data. So when you click here, each and every task is explained very nicely. And these are all the references what I was talking about survey on deep learning, 3D conventional neural networks for the real-time object. These papers are all from the Stanford University papers. People can use it and check. And this is with the tuberculosis, TB prediction. So that's it from my end. If there is any question, I think I'm sorry for the technical glitch in between. I'm open for the question if there is a time. Otherwise, thank you all. I'll stop my presentation. Is that okay, sir?
Yes, ma'am. Yes, ma'am. If the participants wish to interact with the professor, you can unmute yourself and ask your queries, please. Sumati madam, you can unmute and talk.
Where do we get the data sets for cardiac arrest, ma'am?
Cardiac arrest. Cardiac arrest, that's what I shared, the Sunnybrook data, right? Sunnybrook
Can
data.
you please once again share that PPT, ma'am?
Yeah, sure, no problem. This is an open repository where you can use it. If you give Sunnybrook data set, you will get it in your Google itself. One second, I'll share my screen. Can you see here? Just put the cardiac atlas from Sunnybrook. This is one data set and MICI data set. Madam, can you confirm it? Is it visible?
Yes, ma'am. Yes, ma'am. Thank you, ma'am.
Cardiac atlas from Sunnybrook is one data set. Okay. MICI data set.
Okay,
MICI is a very popular data set because they conduct a lot of medical image related conference also. Any other doubt?
Ma'am, I'm doing a research on this topic, ma'am. Can you share me your mail ID?
Yes, madam. I am unable to actually chat with you people. I think my mail ID is chandra.j. Hello.
Yes, ma'am,
Yes,
you're
ma'am.
audible.
It's audible, ma'am.
chandra.j@christuniversity.in.
I will share it in the groups, ma'am.
Yes, sir. Thank you, sir. Is there any other question?
Thank you very much, madam.
Thank you, sir. Thank you for the opportunity.
Archana, madam, we can conclude.
Hello, hello, hello,
You
ma'am.
are.
Yes.
Hello, ma'am.
Dr. Amit,
Am I
you wish
audible?
to interact, please.
Yes, sir. You're audible.
Yes, ma'am. I'm from Jharkhand, Arkajar University, Jharkhand. Actually,
Okay, sir.
I have a query that can this the deep learning model.
Yes, sir.
This deep learning model, it normally it is a supervised type of learning. Correct?
Yes, sir. It is one of the supervised
Uh,
classification.
uh, it is one of the supervised classification. We can also work unsupervised problem also through deep learning. Correct?
Yeah, sir. So that's where we
My
do a lot of
actually,
processing.
now my query is: can we merge two models in this? That is supervised model and unsupervised model in a single means platform. Can we merge it? Is there any way? Actually, I am doing some research on this, and still
Sir,
now I
one
have not
second.
got any
Yeah.
path how to.
Now, the basic thing is supervised is nothing but well-defined data. So when you have a data with a label, we call it as a supervised. Unsupervised means data without label. Most of our
Yes,
social media data is
data loss.
unsupervised data. Sometimes even in medical field, data will be there, images will be there, but there won't be any label or maybe the identification. But then we generally say that all clusterings algorithms are considered as the unsupervised method. All classification models are
No,
supervised classification algorithms under machine learning. But if you wanted to use supervised data as well as unsupervised data, we will normalize, we will standardize, we will go for either unsupervised method or the supervised method. But if you wanted to merge these two things, maybe you have to divide into different steps, split it into different steps. As I had shown, fuzzy C means we applied, but not for the classification, but it is for the some other categorization. So like that, we can use it, sir, no issue. But depending on the problem, we have to actually, make a decision. So generally, I cannot say that you can merge supervised algorithms as well as the unsupervised algorithm. Depends on what
no,
problems.
no. My query is not that, ma'am. Actually, my query is actually merge means I want that it can be it can be cascaded.
Yeah, yes, sir. You can actually cascade.
It can be cascaded. Means output of
Mhm.
one model can be
Can
fed
be
to
given as
the
the input for another. Yes,
input
yes,
of
exactly.
other model
Yes, sir. Yes, sir.
simultaneously.
Yes, sir.
Is
Exactly.
there any reference
We,
for that?
I will tell you. We worked with the brain image. Okay, brain tumor. One of my researcher, and since I'm the research
Hmm.
coordinator, she was under me for MPhil. She applied a K-means algorithm for the
Hmm.
classification. That is for identifying the noise. Then, after the noise identification and the
Then
removal, she used another decision tree method. So you can cascade. That's what I'm trying to say. So first, it depends on the application. So first, for the brain tumor, she used
actually
K-means. That is one of the very popular clustering algorithm. Afterwards, she applied a classification method. You can cascade unsupervised as well as the supervised method if it is really needed for your problem.
same. Actually, unsupervised means that noise only will be the only problem. Actually, my research area also is noise and classification. Means Image enhancement and classification.
You can try for game because
Okay,
it was
ma'am.
working fine for MRI, brain MRI. But people will ask, why did you go for K-means? K-means is very simple. We should have a justification.
And K means actually it is not actually you cannot say that it is cascaded because it is not deep learning model.
Yes, sir. But anything, as long as depending on the complexity of your data, you implement that and then take that output and try to supply and see how it is working. Then only we can actually come to common conclusion that this method can be used or not. So why should I use deep learning? There should be a justification, right, sir?
Yes. Okay, thank you, ma'am. Thank you.
Thank you, sir. Wonderful question. Thank you, Amit sir, for your question. It is
yes, sir. Thank you, ma'am. Thank you very much, ma'am.
Thank you all. I hope.
Archana, madam, please.
Yes, sir. Thank you so much. Appreciate the time you took for being with us, for sharing your for an outstanding presentation in health. You made
Madam?
medical field mainly on
Yes.
cardiac. Thank you for your valuable insights, concepts, all our participants.
Archana, madam, you are not audible, please.
Sir, is it audible, sir, now?
Yes, madam. Yes, but please press.
Chandra, ma'am, shall I ask one question, ma'am?
Yes, madam.
Yeah, madam, can you please give some of the research problems on this particular area?
Research problems on which area, madam?
Machine learning. Related to the cardiac arrest.
Related to the cardiac arrest, there are so many heart-related problems are there. What arrhythmia identification is also detection of arrhythmia is also one of the things. What we concentrated is we concentrated for the sudden cardiac arrest. That is called it as SCD.
Okay.
So I am not. You are very particular about the cardiac related issues.
Yeah, ma'am.
Okay. You can contact me later. I think maybe the next session time is there. They are waiting. So
Yeah, sure, ma'am.
Chandra.
I have your mail ID and contact you.
Yes. Please. So we can actually talk
sure.
offline. Thank you so much.
Yeah.
Thank you so much.
Thank you, ma'am.
Hi, ma'am. Can you hear me?
Yes, madam.
Ma'am, I need a problem on cancer detection, ma'am. You told
Which
about
kind
CT scan and MRI scan, no? CT and MRI.
Which?
Diagnosing cancer.
No, diagnosing cancer means, madam, actually in various organ cancer will occur. So whether you want to concentrate for throat cancer or lung cancer or breast cancer, blood cancer, thyroid cancer, etc. You see, there are various
lung cancer,
types.
ma'am.
You want to concentrate for lung cancer. Okay.
Yes,
what do you want to work with the lung cancer? Maybe you can. I think offline
any
we can
machine
discuss.
learning algorithm which works.
No, ma'am, it is depends on which kind of a tool, medical tool you are going to use.
Okay, thank you.
So what I had shown is we worked with CT and PET, but lung cancer, even MRI people can use. So if your study is going to be with respect to MRI scanning, then you need to search whether the data is available. So it depending on which kind of a medical tool we are going to use. Then later the methods and problems. What is the difficulties for handling the doctors? So our work is actually simplify the doctor's role, and whatever model we are going to build with respect to machine learning, which will be a helping hand or maybe an assistant kind of a things. So if you wanted to work with the lung cancer, please make a study on lung cancer. What are all the medical images?
Okay, ma'am. Okay, ma'am. Ma'am, I couldn't hear you.
Thank you so much, madam.
Okay, ma'am.
For the question.
Thank you.
discuss in offline. Okay.
Yes. Thank you, ma'am.
Thank you, Kiran sir. Thank you all for being.